So the topic of that my invention is that ion exchange membrane system for biofuel, acid recovery, and water purification. So currently the major are three problems in India. First is that we all know that parali is the major problem, and it increased the AQI level of the country. And currently India contains the 500 million tons of agriculture residues, which are very surplus. Out of that 92 million ton is burned. Still there is 140 million ton is a surplus. So it is very challenging to how to manage this that parali burning. This is the major problem. Second problem is that electroplating industry, they are their effluent is acidic in nature, and that acidic effluent goes to the that in the water bodies, and that will affect that contains the metal ions, and that will affect that the health of that premise in that area. And the third is that we all know that water is a major challenge during the next few years, because India is 70% of the country is the water stress region. So what kind of solution I am providing is that the membrane technology is the answer of this all problems. So we have developed the technology that address this all problem using the membrane technology. So we have developed three different technologies. One is that anion exchange membrane system for the biofuel production. Second is the diffusion dialysis system for the recovery of the HCl, and third one is the nanofiltration system for the water purification. The first one is that we have developed the membrane system. That these are all the indigenous membrane system, and these are membrane technology are patented, and we have developed this system for the production of the biofuel using that agricultural waste residue. What we have done is that the agricultural waste residue we have using the two-stage sulfuric acid hydrolysis method, and our membrane is acid resistant in nature, and that membrane used for the recovery of the acid using the electrodialysis system. This system contains two chambers. One is the catholyte, and one is a anolyte chamber. So this anion exchange membrane is positively in charge, and that the sulfate ion goes from catholic chamber to the anolyte chamber under the influence of the electricity, and the glucose present in that solution will not pass through the membrane due to the pore size of the membrane. That's why we will. That's how we will recover the acid, and the glucose left over is used for the production of the biofuel, such as bioethanol or any kind of value-added products. For example, lactic acid, organic acid production, because glucose is the source of the primary energy source. So this technology we have this why this using this technology, we have demonstrated the production of the bioethanol, and we have recovered around 90% of the acid using this technology that can be reused in the next cycle of the acid hydrolysis process. Now our second technology, what we have done, we have procured the HCl effluent from Ludhiana premises, and what we have done that we use that membrane technology under and name is the diffusion dialysis. It is a not current based, it is a based on the concentration gradient. Another, there are two chambers. In one chamber that HCl and Fe plus ion are there, and in another second chamber water is there. So what actually happens, that positively charged anion exchange membrane, chlorine ion will pass through the membrane, but the Fe plus ion too, because they have positive charge, they cannot pass through the membrane due to the electronic repulsion. And because of that, the HCl will be generated in the second chamber, and that Fe plus 2 ion remain in the leftover. So that HCl can be recovered, and that can be used in the next cycle of the electroplating industry. So we have demonstrated this setup at the Ludhiana LWMA, Ludhiana Wire Manufacturing Association, and we have successfully recovered HCl as well as separate the Fe plus 2 ion from this effluent. Now we have developed another technology, that is nanofiltration membrane. What we have done, there are so many textile industries, they are using that dye in their production system. So what is the problem? The effluent contains that large amount of color in their effluent. So problem is that we have to look at another technology, so we can recover that water and the processed water, and that dye will be concentrated. That concentrated dye can reuse in the next phase of their cycle. So we have developed the nanofiltration technology, and this technology we have successfully tested on 10 ppm methylene blue, and we were able to recover around 90% of the methylene blue will be rejected. So that is our three major technology that we have developed in house indigenously, and these are the very effective for the purification of the water as well as that recovery of the HCl or H2SO4. So point is that the technology, the future of the country depend upon membrane technology, because membrane technology is there is no currently in Indian market, there is no player which is developing a membrane technology. So we want to be that, we want to develop that system so we can develop a solution for the so many problem facing in the India. So we have also done the cost analysis. This is for only for that biofuel production. So what we have done that we have taken the wheat straw, the 3 kg mass. The basis was a 3 kilogram of the wheat straw. It will produce around 1.35 kilogram of the cellulose, and the acid hydrolysis efficiency is around 83%, and it will produce 1.12 kilogram of the glucose. So what we have done that we done the cost analysis, and all the aspect was taken. Then we cost of the wheat straw, transportation cost, NOH cost, treating cost, everyone is taken care, and our EED process cost is around 3.92 rupees per kg of the H2SO4. Total cost we have, it the process cost is around, we have also taken care the capex as well as the opex for 3 kg of the wheat straw, around 279.55 rupees. So we have break down the EED cost, electrolysis system, which includes the operational cost as well as that investment cost. So operational cost include that energy cost, and the investment cost include that maintenance cost, membrane cost, amortization, etc. The total cost of the EED will be 3.92 rupees per kg of H2SO4. Now we have done the revenue analysis. The revenue analysis from the first batch, because of the capex and the opex, the first batch, the price of the total revenue will be minus 240.5. And the second batch onward, the revenue will be 1.46 rupees per kg of the glucose. So additional revenue and the return on the investment, we have also done the analysis. We have taken the 3 kilogram as a basis, and the lignin content as a 20%. So it contains the lignin, and the lignin, based on the lignin, we can sell lignin on different prices. And if you use it three scenario, first scenario, the break even will be the 168 batches, and second scenario, break even will be the 34 batches, and the third is break even is 18 batches. So the market size of the bioethanol, it is $34.06 billion predicted in 2017, and will reach to the around 44.4 billion with the compound annual growth rate of 4.861. And the membrane market is 0.643 billion, and it will reach to the 0.95 billion with 5.4% of growth rate. So this is total ethanol capacity. Any question and answer?